What's going on, everyone? Welcome back to Better Biomed, and I'm probably going to release this video on the Take It Apart channel as well, because this is a kind of product that could go with either application. So what I'm talking about today is something called Stabilant 22. Stabilant 22. It comes in a tube. It's this cute little guy right here, but this isn't its final application. Actually, you have to mix it. So Stabilant 22 is a chemical that you place on electrical contacts that coats the electrical contact and prevents corrosion, but at the same time, it supposedly adds to the conductivity of the port of the connector, which is something that I'll probably have to try in another video. We'll experiment. We'll see if that's really what it's doing. But anyway, today I'm going to show you what it is, how we're going to mix it up, and a few of the applications that I've decided that I could immediately start using it on today, just here around the house. So let's check this out. All right, guys, this is the tube of Stabilant 22, and interesting, it's 5 milliliters, okay? And it says electronic contact enhancer. And one of the things that I've been told that this is going to be exceptional for is if you have patient modules that dock and there's pins that corrode. Now, Alaris pumps have the IUI ports on the sides. They're infamous for corroding. And you guys have some of the GE modules and stuff that have pins that tend to corrode. Now, what you would end up doing in those situations is you'd clean the pin or the port with a brass brush. But once you clean something with brass brush, now you've left open, unoxidized metal to oxidize. And as soon as you start putting electrical contact through it, etc., it's going to oxidize probably even faster, since now it's got this breath of fresh air. So Stabilant 22 is supposed to be the miracle product that's going to prevent a lot of that from happening. And if this truly works, it's going to be fantastic. It's going to be amazing, in fact, for everybody in the medical repair industry. So here's the little bottle. It's 5 milliliters, and it says here instructions on how to mix Stabilant 22. So one of the reasons you have to mix it, and it doesn't come pre-mixed, is because if it came pre-mixed, it would have to have hazards, and it would have to be shipped as a hazardous material. Whereas now they can ship you a 5 milliliter, and you mix it to contact strength, and not only does it save in logistics fees, but it also saves you from the fire hazard and the hazardous materials of logistics. All right. So in order to do this, we need 99% isopropyl alcohol. And let's see, is there another type of alcohol that they can say? It says ethanol or isopropyl. Well, I'm just fortunate here in Texas. We have HEB, and they sell 99% isopropyl alcohol. You guys see me use this stuff on videos all the time. This is the stuff you like to use for cleaning electronics because it evaporates almost entirely, no residue left. It just completely evaporates out. It's fantastic stuff. So, and it's also very, very inexpensive. So here we go. We're going to follow the instructions as they say. It's got a little dropper tip here. That's kind of cool. Let's take the tip off the other bottle. Okay, there it is. It just pops out. And it says, empty about 1/2 of the small 5 milliliter bottle of Stabilant 22 into a larger 15 milliliter empty plastic bottle. So that would be this guy. It says empty about half. Wow, that's a slow roll, folks. It is thick. Way thicker than I thought it was going to be. Holy cow, look at that. You see, I'm squeezing the heck out of it. Okay, hold on. That is going to take absolutely forever. Let's pop the top off. I'm surprised that didn't shoot across my desk because I was squeezing it that hard. Okay, I don't need the dropper anyway. Let's do this. Let's pour about half. Right about there. That was a wee bit faster. Okay, and let's see. I'm going to put the top back on this guy. I don't know how volatile this product is, if it evaporates reasonably quick. I have no idea. It's about half. We're good. Wow, that is a thick substance. Pretty cool. I wonder what its chemical composition is. I'm very, very curious. Okay, here we go. It says fill the 15 milliliter bottle with either 99% isopropyl or ethanol until the beginning of the round. So it wants me to fill this guy all the way up. I'm surprised I'm not spilling this all the way across my lap and the desk. I'm going to place the top back on, like so. Place the screw cap back on. And it says to give it a good shake, shake, shake. All right. So it says a 3-to-1 solution has been formed. And this right here is the concentration strength for application. All right. It seems to have dissolved quite nicely. It definitely made the alcohol a little bit thicker. So I believe that the alcohol is a carrier. And what you're doing is you're thinning this out so that when you spread it across a contact surface, the alcohol is going to evaporate and the remnants are going to be your, would it be an insulator? It's an insulator from the elements, but at the same time, it's a conductor because it's supposed to be very conductive. Interesting. Okay, so I believe I've mixed it up strong enough. According to their instructions, comes with 3 of these very interesting little brushes. And I have a variety of applications here. Okay, it says now the Stabilant 22 is ready for application. It's approximately 75 to 25%. Now, how are you going to use Stabilant 22? As I already said, if you have patient modules or something and you have external contact points where accessories attach and detach, telemetry modules, stuff like that, definitely put some of this on there because there's going to be a lot of artifact at any connection point. This stuff is going to help alleviate that. Now, the applications that I've thought of, I'm gonna use this little cap that came with the use the cap that came with the roll here, the shipping roll. So we got some in there. Now, the applications that I've always had a problem with, one of them is going to be flashlights. Oh, this is so annoying. Flashlights, I did a whole video on flashlights on the Take It Apart channel where I show all the defects and places where they can make flashlights better. One of the areas that we always have problems is the connecting point to the end cap. It's this threaded in-body experience right here. And the problem is it either corrodes right here at this connection point or it just has poor connectivity. So what I'm going to do is I'm going to treat all the threads with this material. And of course, we're going to let it dry. And then also, alkaline batteries leak. So since they leak, one of the things I want to do is paint all the springs and contact points. Even if you guys have children's toys, holy cow, those batteries leak so often. Treat all the contact points. Put it together, allow it to dry, you're good. Here, I have another example. This is another flashlight. This one here, it's got this ring where it conducts electricity. And the problem with flashlights is that if it has poor conductivity, with the newer digital lights, they'll just shut off. And then you have to click, click, click to get it back on because they have multiple functions. It's very annoying. So here, you can see on this battery pack, I'm going to paint the 2 terminals where it is going to connect because I want maximum conductivity right there. There we go. I'm going to set it over here to dry. Dry. And the flashlight head. This guy here actually was kind of iffy. Depending on how I touch it, it would have better or less conduction right here at that ring that you see. And that was creating a lot of hell for me. There we go. Painted those conduction surfaces. I'm probably going to do a follow-up video on this where I'm actually going to spray an oxidizer on contact points. And we're going to test to see if this actually does prevent oxidation. Here I've got 4 pins in this round connector. Not quite a DIN connector, but I think this is a LEMO connector. There we go. So what I'm doing is I'm just painting each of the pins. Set that off to the side and dry. Now these ones here, these round conductors, the round terminals, they have a problem with corroding all the time. Let's try something else. If you use power tools, Guys, I don't know if you've ever taken a look right here in these battery terminals. You can see that this guy has had a few hot suppers in his day. Well, that means that this guy here also has probably poor conductivity. So what we're going to do is we're going to just put a whole bunch of this right here on these terminals. Interestingly enough, since it's dissolved in alcohol, it's also cleaning the metal. I can see it cleaning the metal as I paint it on. Crazy. Yeah. There it is. Yeah, for sure, it's cleaning the metal. So not only is it cleaning off the garbage that was preventing conductivity, but it's creating a superconductive layer on the outside. All right, so I just treated a tool battery, which I know that tool battery is it's good. Let's move on to some more industrial electronics. So there's some places where you're always going to have problems with industrial electronics. One of them are going to be your RS-232 ports. So right over here, I'm going to paint the pins on this RS-232, the DB9 port. These communications ports can be intermittent, especially if there's a lot of vibration in the equipment. So you want to make sure that the terminals are as treated as possible so that when you connect a communication cable to it, that it's good to go. I could, of course, put some in each of the holes on this guy, but I don't really care about those. The one thing I do care about are some of these terminals over here. If you ever see these, JT terminals or JST type terminals, these ones here will also oxidize. And as soon as they start oxidizing even a little bit, the connector is going to show discoloration because there's heat buildup. So let's start it right at the beginning before this one here goes bad. And let's treat these terminals. Since this is 99% isopropyl alcohol in the beginning, you can actually see that it's drying reasonably quick. There you go. All right. That's looking pretty good. Now, one of the other things I wanted to point out is that you can get intermittent failures quite frequently on interboard connects, like right here. So if that was something that I was really concerned with for this board, I would separate these two, and all these interconnect pins right here and over here, I would treat all of those as well. And then as soon as it dries, put it together. And over here, these here are motor terminals. So these ones here have higher current, and I can see a little bit of oxidation on them right now. Anytime you have high current flowing on smaller conductors, you're going to have oxidation. And there's a breakoff point. When you get to a certain level where you have a certain amount of current going through and you have a certain amount of resistance, it accelerates the corrosion. And from there, it's exponential. The amount of resistance goes up and heat goes up, and then it melts the terminal, these guys right here. So these little Molex style connectors, especially since these ones here are for motors, I'm just putting it down there and I'm going in circular motion around the pin to make sure that the whole pin is coated. Actually goes pretty quick. I dig it. Last two pins. There we go. All right, guys. That is actually pretty easy to treat. I like it. And the last of them, let's try this older style glide scope right here. Now, I can't really get it in there too well, so I'm going to put a drop. There you go, inside the holes. This is old style analog video. And since it's old style analog video, you will get like some garbage on the screen. I could be wrong, but I'm pretty sure that this one's analog. The newer ones are all digital. If you guys have RCA cables anywhere in a treatment area, whether or not they're carrying audio or video, a lot of video towers still to this day use RCA cables. I highly suggest treating them with this because that is definitely an analog signal. And analog signals are very susceptible to interference and poor connection. This is going to save you a lot of heartache. Just treat stuff while you can. You can see I treated all this stuff and I have barely used any. So this little bottle right here, this could treat probably an entire fleet of infusion pumps if you're painting all the terminals. Good stuff. Anyway, guys, that's a Stabilant 22. Pretty good product, man. I bought mine off Amazon, and also I had some donated to me. I'm very thankful for that. And I'm going to actually be doing some trials in some hospitals here in Texas, where we are going to be putting this stuff on patient modules and stuff, and we're going to test it out and see how well it does. We'll probably do a follow-up video 6 months to a year later and see how many problems we've either solved or created in medical equipment. Now, I do know that Myra, the Biomed girl, she just had a video not so long ago about a very particular pin that's always corroding on patient modules. And I have also seen that, and it's very frustrating. Just remember that when you clean off the corrosion from those copper conductors, that you immediately use a brass, not stainless steel, use brush, and then immediately treat any exposed metal with Stabilant 22. As soon as you're done, flush it with alcohol, treat it with Stabilant 22, let it dry, put it back together, you're good to go. Anyway, guys, hope you liked that video, and I'll let you know how the results are in a follow-up.